first section of the chapter is going to be operations on functions. Today you will have some familiarity, okay, with the operations of what we do. What's going to be different is how it is presented to you. Okay? And the presentation of it is going to be... Yep.
Does this need to be written?
Yep. Right here.
Just the titles of them?
No, write the whole thing.
Alright.
Right there is how they will be given. Circled in red. F plus g of x. F minus g of x. What you're given now, instead of just be given one function and doing stuff with it, we're going to be given two functions. You're going to add them together, you're going to subtract them, you're going to multiply them, you're going to divide them. The notation that will be given to you in is circled in red, with given, with an arrow pointed. The notation you'll actually make use of this stuff in is circled in blue. Okay? Here's why. The x you see right there. See that x? Where'd you go? There you go. Okay? Without knowing anything, if I just gave you f plus g in parentheses and then x touching it, what do you think? Distribute, right? Okay? Same diff, same diff. Okay? Distribute, right? That's what gets people thrown off. They see this, they go with their instincts, and they think it's distribute, which in this case it's not. It is a fancy function notation. Okay, you have f plus g of x. That's how you say that guy. The real use of it is to take f of x, g of x, and add them together. So if you look at this row and you look at the examples, so they say f of x is 2x, g of x is negative x plus 5. They take 2x, they take negative x plus 5, and then they what? They add them. They add them up. 2x plus negative x plus 5. 2x plus a negative x gives you x, and then just 5. They combine like terms. That's all it is. It's combined like terms. It's just how it's given to you. Okay? Same with the subtraction. F minus g of x. You think distribute, but it's not. It's just notation-wise. It's f of x minus g of x. F of x in this case is 2x. Same case as though g of x is negative x plus 5. You put it in parentheses, you subtract them. 2x minus a negative x gives you 3x, and then minus 5. Combine like terms with a subtraction. Multiplication down here, f times g of x is f of x times g of x. So f of x is 2x, g of x is negative x plus 5. Multiply them together, distribute to 2x. Negative 2x squared plus 10x. Those three are normal, okay, as far as the operations goes. Combine like terms, distribute, what we've been doing. Questions on those three? Division's a little odd, okay? Division's a little weird. I want you to make note of this part right here. Yes, that's a comma. Okay? The notation for division will be given f over g, in parentheses, of x. Circled in red there. The useful stuff is f of x over g of x. G of x cannot equal 0. Why would that be? Why would they put in there that g of x cannot equal 0? Because you can't divide by 0. Right? You've known that for a long time. You cannot divide by 0. Okay? Long term, where we are going, we are going to have to start talking a lot more about these two words we talked about very, very early on in the year, domain and range. Okay, remember that? Okay, domain are your what? Anybody remember? Domain are your x's, range are your y's. Okay? We're going to have to start talking more and more about that as we move into the book later on. That starts with this. Okay? That starts with g of x not being able to be 0. Because you have to tell me what number you cannot put into your function. What number you cannot put into x. And that number is whatever number would make the denominator be 0. In this case, 5. You plug 5 into x, negative 5 plus 5 will give you 0. You cannot divide by 0, therefore you can't put in 5. That's all you have to do with it though. No synthetic division, no cancellations, no nothing. Okay? Okay, so, given f of x equals x minus 4, g of x equals 2x plus 1. Find each function, indicate restrictions in the domain or range. That's your fancy words for the denominator stuff, so we'll get to that in a second, okay? So number 1, you have f plus g of x. Get in the habit of turning it from the notation you're given into the notation that's useful. So f of x plus g of x, like that. Now, f of x is what? X squared minus 4. So you sub x squared minus 4 in for f of x. What's g of x? 2x plus 1. Sub that in for g. And what are we doing to these two? You're adding them. So you combine like terms. X squared plus 2x minus 3. Okay? So the second one, switch to useful. Alright? So f of x minus g of x. Same two functions. Okay? F of x is x squared minus 4. G of x is 2x plus 1. And what are we doing with these? Subtracting. And when you subtract, the second thing you're subtracting, you should always put in what? Parentheses. That still holds true here. So that negative sign between the two functions, you got to do what? You got to flip their signs. You got to distribute it. So x squared minus 4 minus 2x minus 1. And then, like terms. X squared minus 2x minus 5. Okay, so next one. F of x equals x squared plus 7x plus 12. G of x equals 3x minus 4. Find each function, your two new functions. Okay. This time we're going to multiply once and divide once. So f of x times g of x, like that. F of x goes in for f of x spot, which is x squared plus 7x plus 12, g of x, and for g of x's spot, which is 3x minus 4. Multiply it through. X squared times 3x gives you what? 3x to the third. X squared times negative 4 gives you negative 4x squared. Move on to the 7. Bless you. 7x times 3x 21x squared. 7x times negative 4 gives you negative 28x. 12 times 3x, 36x. 12 times negative 4, negative 48. It's a chapter 5 question, right? Okay.
Didn't you forget to the square? Right? Yeah, you forgot the square.
On
21.
21. Thank you. Okay. It's a chapter 5 question. It's just I make you take these two things and put them together. Chapter 5, I could just give you this and be done. Now you had to understand the function notation, putting this together. Make sense? Okay. Still got to what? Combine like terms. So go through and do so. 3x cubed plus 17x squared plus what? 8x minus 48. Okay. Questions on that one? Your division is kind of weird, okay? It's kind of weird in the sense that it's easy, but it's weird in that you have an extra step, okay? The useful stuff is do f of x over g of x, which literally means take f of x, which in this case is x squared plus 7x plus 12, and put it underneath g of x, which is 3x minus 4. That's half your answer. Okay? F over g. Okay? But remember from the first slide, the only thing you have to do different here, you have to take your denominator and you got to figure out what number you cannot put into x. And that number, whatever that left side is going to be equal to 0. So you set that up. You take the denominator, you set it equal to 0, and you solve that equation. Okay? So add 4. Divide by 3. Okay. It is. And chances are they will be. Okay? But just leave them as fractions. Alrighty? That's your answer. Those two. I need to see the division itself, and for division, I need to see that number the denominator cannot be. I gotta see both. Next slide. Do not write down. Okay? Write the title. Write composition of functions. Don't worry about the model. Don't worry about all these. Okay? Okay. F of x. Right here. Actually, hold on. Slow down. There we go. F of x equals 2x plus 7. G of x equals 3x minus 5. Okay? I made that up out of my noggin. Just watch. Just watch. Just watch. Just watch. Just watch. Okay? Watch. Find G of 3. Yeah, very good. Find G of 3. There it is. What do you do with this 3?
Don't you gotta plug it in?
Plug it in for in
3x
and 2x.
in G. There, you guys, you're there. Just say G. Okay. You plug 3 into the x in G. So right there. Okay. So 3 times 3 minus 5. 3 times 3 is 9. 9 minus 5 gives you 4. Not news, right? That's old stuff. last chapter stuff, to be honest. Okay? Now, find F4. How'd you do that, Slaughter?
Plug it in where the X is.
In.
Times 4 is 8.
Hold on, slow down. Plug 4 in where the X is in F function. Good. So 2 times the 2 we're plugging in plus 7. 4. My fault. 4. 2 times 4 is 8. 8 plus 7? 15. Nope.
You just lose the X one? I mean, not the vision, but there no.
Guess what you guys just did? You did a composition of functions. Okay? That's what you did. Okay? You did 2 functions at the same time. That's all this is. Okay? That's all that model mess means. That is all these nasty words mean. You just do it twice. You do inside, you do this one, then you take that result. Because everybody see where I got Everybody see where I got 4 from, right? Yeah. It's right there. I got 4 from.
Yeah.
I got 4 from right there. If you notice, I didn't write this question until I got that number. Everybody see that?
Yes.
Okay?
So is that why you put the 4 right there?
That's exactly why. Okay? I knew I needed 2 functions, and I just made up a number, g of 3. Cool. Okay? All right. Now, what you do, does everybody have that down that wants it? Okay? Okay, what you do need from this slide, and I'm going to rewrite it, is this little bit right here. Okay? Now, what we just did is called composition of functions. The useless notation is going to look like that, just like last time. Okay? F of g of x. That's what this little degree symbol. That's a degree symbol. Okay, see how it's an open circle up here?
Yeah.
So it's not multiplication. It's a totally different operation. And what that operation means is to do what you just did. Okay? That's all it means. Much like the first 4, there's a much more useful notation for this. It looks like this. F, G, X. Double close. Okay? So to make this make sense, someone that wrote that down, f of x was what last time? It was 2x plus 7, g of x.
3x minus 5.
3x minus
The question will say, do f of g of 3. That's how it'll be written. Because what did we do first? I told you guys to do g of 3. So that's how it'll be given to you. G inside first. And then you did f of 4. You did these inside out. This notation right here, make sure you know how to go to it. Make sure you know how to go from here to there. Because it makes compositions a lot easier. All right? Any questions so far? Everybody good? All righty. Next slide. Let's do some. Okay. Using the functions f of x equals 2x minus 5 and gx equals 4x, find each value. We're going to find f of g of negative 2. We're going to find g of f of 7. We're going to find f of 6. So you find your innermost function letter, g. We do that part first. So we're going to do g of negative 2. So we're going to take negative 2 and plug it into the x of g, which means we're going to multiply it by 4. So 4 times negative 2, which gives us negative 8. Okay? So see how g of negative 2 equals negative 8? You see that?
Yes.
Okay? So now g of negative 2, you can substitute negative 8 in for that. So now you go f of that negative 8. You take the first result, plug it into your next function, next letter. All right? So negative 8 into f now. So 2 times negative 8. Because you're going into f now. Okay? 2x minus 5. So 2 times negative 8 minus 5. 2 times negative 8 gives you? Negative 16 minus 5, which gives you? Negative 21. Other way. Okay. The last number, technically speaking, the last number is the number I need to see. But you got to use the negative 8 in order to get there. Okay? So you got to do both. Last chapter we did one at a time. Now you do it 2 at a time. Okay? Make sense? Second one, g of f of 7. I always say work these inside out. Okay, that's pretty much how I run them. So we're going to do f of 7 first. So we plug 7 into x, which gives you 2 times 7 to be 14, minus 5 to give you 9. And now that you know that f of 7 is 9, you plug 9 into g, which is 4 times 9, which gives you 36. Okay. Last one, f of 6. Same way, inside out. Do f of 6, which is 2 times 6 minus 5. Got her in there? Yep. 2 times 6 is 12. 12 minus 5 gives you 7. So now you found f of 6 to be 7. Now you're going to go find what? F of 7. So even though it says f, you do it again. So 2 times 7 gives you? 14. Minus 5 gives you? 9. Inside out. Okay? Now, just in case, I'm going to change the last problem there just a little bit. Do it in white. Just pay attention. Now what?
You plug 9 into G.
Now you would plug 9 into G. Which would give you, ironically, 36. Okay? So however many function letters you have listed out there, you do it that many times. Inside, out. Innermost letter, that number. Get a number. Get a new answer, I mean. Take that new answer into the next one. Get another new answer. That answer into the next one. That answer into the next one. So on and so forth. Okay? Okay, for each pair of functions, find f of g of x and g of f of x. And they put if they exist in case something funky happens, they'll exist for you. Okay? Now, that notation is the notation you will see on a test and book on the ACT. Yes, these are on the ACT. The notation that makes them make sense is the one where you put parentheses. They're different. They're open. They're degree signs. They're open circles, which is not multiplication. So f instead of the degree, put a parenthesis, g, another parenthesis, and then x, and then double close. That's how you set it up. That's the notation that's going to help you make this make sense. Okay? And that's the hard part, to be quite honest. That's the hard part right there. Yeah. And then do the other one. I'll do it in blue. So G, parenthesis, F, parenthesis, X, double close. Okay. I'm going to do some cutting and pasting here. We'll move you here. We'll move you right there. Okay. You work these problems the exact same way. The exact same way. Okay. Innermost function letter in this one is G. Okay. So what's G of X? 4x. So see how we already have G of X equals 4x right here? Oh, that's great. So we're going to take 4x and put it right here. Because that's what G of X equals. Now, what are we going to do with 4x? Multiply it by 2 and then subtract it by 5. Into F. You're going to take 4x. Once you figure out G of X, right? G of X is 4x. Set it up like this. Now you put 4x into F. So it's 2 times 4x minus 5. So what's 2 times 4x? Done. Okay. The blue one. The blue one. Or how does he say it? It's not really blue. It's more like a blue Prius.
It wouldn't be. It wouldn't be
Anybody?
3x. I thought because we had. So we put the whole equation.
What's F? What's F of X? F of X equals 2x minus 5. Whoop, whoop, G. And you replace G's X with what? Nuh-uh. That is G. You replace G with. Hold on. Slow down. You replace G's X right there with what quantity?
Oh, that equation.
That whole thing. 2x minus.
I thought it was just. I didn't know we could do
2x minus 5. Yeah. So equals 4 times what you're plugging in, which is 2x minus 5. Not this one. Separate side. Separate problem. It's two separate problems.
that.
2 separate problems. Okay. What do you do with this for? You distribute it. Done. Okay. Hurry up. Okay.
What made them 2 separate problems?
It's because you're asking to do it twice. For each pair of functions, find f of g of x and g of f of x. They're two separate questions.
All right, when it says and, that means they're separate.
Yes.
And if
In this notation, yes.
and if it's not, if they don't say and, it's not. Like, it's just,
Right. It'll say find this one and that one. They're two totally separate different things. Okay? Everybody good here?
Yeah.
Okay. One more. I'm going to ask you, let me make sure I get this right. Get this right. You don't need to find both. I just want you to find f of g of x.
Would it be x cubed?
No. Let's get that notation right. Okay, let's do that first. So f parenthesis g parenthesis x double close. Okay? So that's the only one I asked you guys to do for this one. So f of g of x. What's g of x? x minus 6. So replace this guy with this guy. Okay, so f of x minus 6. Okay, now you substitute into what? Into x. Okay, what's happening to x in right here? It is being squared. So whatever we plug into that x, it also is going to get what? Squared. So, and what are we plugging in? X minus 6. And it needs to be squared. And then we have to do what to it? Add 2. This is why, this is the version of, like, have you ever heard anybody talk about machines and math? No? Good. I don't like that analogy. I really don't. Okay? It's what you're doing to x. You're squaring x and then added 2. Cool. Now, the question becomes, how do you square this? Robert? How do you square a binomial?
Like, do it twice, basically. Like, x minus 6, and then, like, 4 factor, what? Factor?
4-lettered.
Foil.
You foil. You foil. Okay? X minus 6 times x minus 6 plus 2. You foil the x minus 6 since it's being squared. It's a binomial. Okay? So that foil becomes x squared. 2 minus 6x is in the middle, which becomes minus 12x plus 36 plus 2. Last step. Like terms. X squared minus 12x plus 38. 6. It ends up being 9 problems. Okay? 9 problems, but 8 through 10 are 4 parts each. That's the first ones we did, where you have add, subtract, multiply, divide. Okay?
That's it, we don't do the extra ones? The ones we get?
No, you will later. You will in those other 2 sets. Okay?
It's the 7.